Okay, please come in. We have some more seats in the front. It's pretty harmless, right? I won't throw stuff at you, you know. So it's all fine. You can sit right here. More seats in the front. You can come all the way up here. Looks like it's going to be a full room. Wow, impressive. All right, please move all the way to the front. We have some more seats here. You will have a perfect view on SageMaker, right? Even more impressive when you take a look up close. All right. So welcome, everybody. I hope you enjoyed the keynote. My name is Julian. I'm a tech evangelist with AWS, focusing on AI and machine learning. And the really cool thing about this session is it's completely free of slides, right? So that's why you're here, I guess. So 0 slides, and we're going to talk about SageMaker. Actually, we're going to use SageMaker. We're going to run through some demos and see what this service can do for you. Okay? So maybe just a quick show of hands before we start. Who is a developer? Who's writing code every day? All right, welcome. Who's doing machine learning, even at small scale, even small stuff? All right, quite a few people. All right. Okay, so I guess you heard about SageMaker already because it's been out for a few months now. It came out at reInvent, and it's a new service that lets you build end-to-end machine learning workflows. And the key promise, actually the key feature in SageMaker is that you focus on the machine learning task and you actually spend no time managing any kind of infrastructure. And as you probably know, if you already do data processing and machine learning at scale, the actual DevOps part of machine learning is quite important. You know, you have to build training clusters, prediction clusters, and sure, it's important. Those things need to work properly, but they just stand in the way, right? When you do machine learning, you want to iterate fast. You want to explore different algos, different models, different parameters, and the last thing you want to do is having to mess with EC2 instances and big clusters that you have to manage yourself. And this is what SageMaker solves for you, among other things, all right? You can please move all the way to the front. We have some more seats, right? You don't want to stand. So what I'm going to do today is just run a few demos, a few different things, use some of the built-in algos in SageMaker, show you as well how to integrate Amazon SageMaker with Apache Spark, which I think is an interesting use case. And we'll see, and time permitting, we'll just run more stuff, right? There's plenty. So for those of you who've probably never used SageMaker, well, this is the console. It's super simple. One thing that you might want to start with is create a notebook instance, which is exactly what the name says. It's a pre-installed instance that comes with all the Python and all the deep learning tools and the Jupyter environment that you need to get started. So I'm not even going to show you how to do this. You just click on Create Notebook Instance, and you fill a couple of parameters, and it's done, right? So now when you open it, you will actually jump straight away into Jupyter, okay? You will see a number of existing notebooks that are already installed here. These are really, really good examples. If they please show up, yeah, here they are. You'll see those sample notebooks, right, that are here. They're also available on GitHub if you wanna look them up. I really, really recommend them as a great learning resource. So let me find those things here. SageMaker. Yeah. And I would say if you want to learn SageMaker, reading the documentation and going through those examples on GitHub is probably your best bet, right? Okay, look, I have slow internet right now. Okay, that's fine. Let's open that page later on. Okay, so I'm going to use some of those notebooks today and some of my own. So let's start. Let's start with the first example. So SageMaker. Oh, let's go all the way up here. Can you read in the back, or is it too small? Yeah, is it good? All right, thank you. If it's too small at some point, just wave, right? So one of the cool features in SageMaker is actually the collection of built-in algorithms that you'll find there. So it's not just a service that lets you manage infrastructure easily. It's also a service that provides a number of built-in algos that have been implemented by Amazon and AWS, so you can expect them to scale. And you can just take those off-the-shelf algos and get the job done, okay? So here's an example of that. Sure, you'll find, I would say, the traditional stuff, you know, linear regression and clustering and classification, etc. But you will also find some more advanced stuff, and this is one of the more advanced stuff, more advanced one. It's called DeepAR. It's actually been invented by AWS. There's a research paper for that. And this algo lets you build time series, lets you predict time series. So let's take this algo and see what we can do with it. So here I'm going to use a data set from Berkeley University. And it's a data set storing world temperature. Okay, so there's a daily measure, a global temperature measure for every day since 1880, right? So first thing I need to do, of course, and again, I am working on a notebook instance here. I need to download this data set, remove some useless lines that I don't need. Okay, and this is what my data set looks like. Okay, a few columns, you know, date, well, year, month, day, and the temperature, which is actually, it's not the actual temperature, it's a delta versus a global average. Okay, but I'll convert it again. Okay, so I have temperatures from 1880 to 2014. Average temperature was 868 over that whole period. So these deltas here are actually need to be applied to 868. And let's say I want to predict 30 days of temperatures, okay? So whenever I have a time series, I want to predict the next 30 days. So that's what we call the prediction length, okay? So I'm going to, I need to load this file, okay? So first thing I need to do is to actually build the time series themselves. So I'm going to load this file using Python, put everything in a Python dictionary, just make sure I have one entry per year with all the temperatures, right? This is really Python stuff here, okay? And so when I'm done with that, and don't worry if you don't understand the finer details of Python, all that stuff is on GitHub. I'll share the link at the end. Once I've done that, actually I've loaded my file as a Python dictionary, and hopefully, yes, I've got either 365 or 366 measures for each year, right? Which means my data is complete. So now I can actually plot it. It's something that we usually do when we work with data. We want to take a look at that data set. So there you go. Global temperatures from 1880 to 2014, right? Come up with your own conclusion. I'm not here to talk about politics. I'm here to talk about machine learning. Okay, so yeah. Anyway, so then I need, as always, to split my data between a training set and a validation set. Okay, it's what you do when you do machine learning. You use the bulk of the data to train, and you set some data aside to actually measure the accuracy of your model. So when you work with, I would say, like, traditional algos, like probably, let's say, linear regression or classification, you just take the data set as it is, and you split it maybe 80-20 or 90-10, and that's it. For a time series, it's a bit different, because actually the training set will be, the test set, sorry, will be the full data set, okay? Because we want to compare the predicted time series to the actual values that we have initially. And the training set is the full data set, okay, minus, in this case, the 30 last data points in each time series. So my training set is actually the time series for each year where I remove the month of December, right, the last 30 data points. And that's what I do here, right? In my training set, as you can see, I just copy the full set minus the last 30 values, and the test set is just everything. That's how you work with time series, okay? So yeah, I do have a bug for 2014, so I'm just ignoring 2014. Not sure what's going on here. Okay, so now I've got my training set and my test set. So I need to write those to files, and I need to pay attention to the file format that DeepAR requires. Okay, and you'll find all of that in the documentation, so no worries. So DeepAR requires the time series to be stored in JSON format. Okay, actually JSON lines. So each line, as you can see here, okay, each line in my data set is going to be one JSON document. So this is 1948 for whatever reason, and then the target array is actually the 365 values for that year, okay? And it's the same for every single year, okay? Here's 1949, etc., etc. So I need to write those, that data set into that JSON format, because again, this is what DeepAR expects, okay? And for different algos, it's gonna be a different format. I mean, a lot of the algos use protobuf. Some of them can also take CSV, but DeepAR is a bit different. It takes JSON. Okay, so now I've got locally on my notebook instance my data set in JSON format. Now I need to upload it to S3 because this is where SageMaker is going to pick up the data. Okay, so define some locations in S3, upload the training set, upload the test set, define the location where the trained model will be saved. Okay, once again, all activity happens in S3. Your data must be in S3. And the model will be saved in S3, okay? And I can see all the different paths here, okay? So that's it. So now our data set is ready and uploaded in S3, and now I need to actually configure my training job. And as you may know, if you look under the hood of SageMaker, it's all running on Docker, okay? So all the training jobs and all the prediction jobs are actually based on Docker containers, okay? So what I need to do here, basically, is to select the container that contains the DeepAR algo for the region I'm running in. So here I'm running in US East 1, so I will just go and pick the image that corresponds to that region, okay? And again, all those containers are defined in the doc, so you don't need to go and search for that, okay? And as you can see, they're hosted in ECR, which is our Docker repository, okay? So that's the algo I'm going to use, right? DeepAR, hosted in US East 1. And now we get to the good stuff. We get to actually configuring the training job. So I'm going to use the SageMaker SDK here to do this. It's a Python SDK, and we have this high-level estimator object that lets us define everything. So I'm going to select the container that I need, okay? Pass the IAM role for SageMaker because it needs permission to access S3 and so on. And I'm going to use one C4 8XL instance to train. And that's as much infrastructure as you need to work with, okay? If you wanted to do distributed training and you wanted, let's say, 10 instances because you had a really big data set, that's what you would do. And SageMaker would automatically fire up those 10 instances. And they're fully managed, and they terminate automatically once training is done. So you never spend a minute managing those servers, okay? Which, again, is one of the key features in SageMaker. Okay, so that's the training job. I need to define some parameters. So these are more algo specific, obviously, so I'm not going to go through all of them. But the important ones are prediction length. Okay, so I want to predict 30 data points in that time series. My values in the time series are actually daily values. You can go from minutes to years. Okay. And then I can define some parameters for the structure of the DeepAR network. I'm going to train for quite a while, 250 epochs. I can define the batch size. I can define the learning rate. So again, these are algo-specific parameters, and you can find them in documentation. And of course, you can read the research paper if you want to know exactly what these are. And this one's interesting too. It's called early stopping. Actually, you never, when you train for the first few times, you never quite know how long you should train for, right? So you could actually train for a huge number of epochs like this, and define early stopping. And early stopping really says if the accuracy of the model hasn't improved in 10 epochs, stop training. Okay, so it takes the guessing part away. You don't have to run multiple tries and say, okay, did I train for long enough? And no, should I try for longer or maybe longer? Just define a large number of epochs and early stopping, and then it stops automatically when there are no more improvements. Okay, so then I can set the parameters for this algo, define the location of my training data, my test data, and then train. Okay. And so what this does is automatically it's going to fire up that instance that I created, pull the Docker container storing DeepAR to that instance, inject your parameters, point everything at your data, and then it trains. Okay, so it trains for a while, and you have that the full training log. Okay, and this is also available in CloudWatch logs. Because sometimes you're not using notebook instances, you're just running training jobs automatically. So obviously you need a place to go and grab the log, and that would be CloudWatch logs. Okay, so it trains for a while, and I guess it does get stopped early. What's the last epoch here? Yeah, epoch 119. Okay, so it does actually use early stopping to stop. It saves the model in S3, and then I can deploy it. Okay, so when you deploy models, you could just deploy it. You could basically say, you could use that same object here, and you could say estimator.deploy, and it would just deploy it in a very simple and automated way. Or you could maybe go down one level and use more custom behavior, and this is what we do here. So actually, when we deploy, we first create an endpoint configuration, and then we deploy. And the purpose of that endpoint configuration, which you see here, is it lets you configure multiple models behind the same endpoint. So let's say you have an existing model that you trained last week, and you want to deploy the new model that you just trained. You could actually keep the same endpoint, keep the same prediction endpoint running, and have the two models actually running behind that endpoint. And you can split traffic across those two models. Or it could be 2, 3, 4. Okay, so it's just a good way to do maybe A/B testing, or it's a good way to do very safe deployment, gradually bring a new model into production, and check that everything is fine, and then switch all traffic to the new model. Okay, and you can see this in the you can see this in the SageMaker console as well. Okay, you have this endpoint configuration, which is really what is the model, or what are the models that are actually living behind the endpoint, and then you have the endpoint itself. Okay? So this is what we do here. We deploy it to a single M4 XL instance. And once again, automatically, SageMaker will create the instance, deploy the model, and create the HTTP endpoint to start serving predictions. Okay? And again, you see here, we could, that's probably this one here, yeah? Okay, and here's the URL, okay? So now we could HTTP post new samples to this endpoint and get some predictions, okay? So let's try and do this. So I'm going to build a prediction request, And again, it needs to be JSON formatted, okay? So it needs to look a bit like those samples you saw previously, right? So it has a start, and it has a target, etc. So I just need to come up with that. Again, when you predict with a time series, things are a bit different. When you predict, let's say, when you classify samples, you get a single result, right? You get a single prediction, and that's what you use. When you predict with time series, actually you predict a number of predictions, right? And this is this num samples thing that you see here. So you're going to ask that model to predict maybe 50 samples, okay? Because time series are extremely volatile. So from one to the next, you could have a lot of differences. So if you predict just one value, it doesn't necessarily give you a perfect view of the result here. So actually, we're predicting many different time series, and we are asking DeepAR to output the mean for those let's say 50 samples, and as well as the quantiles. Okay, so you could ask for the 10th or the 19th quantile, and for example, the 90th quantile value, as we will see, tells you that 90% of values are actually lower than this, right? And so it gives you like a statistical view of the time series predictions. Okay, so that's what I need to build here. Okay, then I need to extract some information, and I want to plot it, and this is what it would look like. Okay, so let's say I want to compare. I want to check if my prediction is actually good. So I'm going to compare the prediction for the last 30 days of 1984, and hopefully that rings a bell, to the actual values. So I just use those functions that I showed you, right? I built a prediction request. I actually used the SageMaker SDK to HTTP post that request to my model, and then I can plot my results. And as you can see here, I see, so is it purple on the screen? Yes. The purple line is the actual, is the truth, okay? So it's the values from the data set. The blue line is the mean from the samples that I predicted, okay? So again, I asked DeepAR to predict many different samples, and the blue line is the mean of that, okay? The yellow line is the 10th percentile, so 10% of those predicted values are lower, and 90% of the predicted values are higher. The green line is the 19th percentile, so that tells me 90% of the predicted values are lower, and 10% of the predicted values are higher. So that channel, right, the channel between the green and yellow line are actually a good guess that my predictions should be there, right? 80% of my prediction should actually be in that channel. And if I plot a single sample, that's the red line here. Okay, so actually we see that if you compare the purple line and the blue line, they're pretty close, right? And the purple line, except for that end over there, is pretty much within the channel that I defined, right? So it gives you confidence that your prediction is kind of okay, actually. So now you have to decide which one you want to use, actually. Okay, if you need to use one single time series in your app, which one would you take? So let's take an example. Let's say you're predicting attendance for a restaurant, right? You want to know how many people will show up at your restaurant tonight, because you need to plan for, you need to shop, and you need to have maybe extra staff, etc., etc. So if you predict and you use the 19th percentile, okay, this is a very conservative prediction, because again, 90% of the real predictions will be lower than that. So you could buy food and plan for staff according to the 19th percentile, but then again, most of the time the real value will be lower. Okay, so maybe you spend too much money on food, and maybe you plan for extra staff that's not really needed. So you could say, okay, maybe the mean is a more reasonable way, right? Because the mean is like, I could use the mean, spend less on groceries and stuff, and have maybe some contingency plan if there is really a peak of an unexpected peak of attendance. So again, depending on your business problem, you might use maybe the mean, or you might use the 90th percentile or something else, okay? But this is pretty much how you work time series. And here's another example. So I just built a bogus time series with temperatures for 2018. Okay, so just with a mean of 9 and a variation of 3. So I built 90 values here. Okay, and I try to predict the next one. Okay, and again, well, these are my predictions for the next 30 days following my time series. And well, again, you can see, you know, the random sample, the red one, is pretty much straight in the middle of the channel. So, you know, it looks like my prediction is working, right? It looks like my prediction is working here. So again, you could decide which one of the percentiles you want to use, okay? And then when you're done, of course, you can clean up and delete everything. So this is the first example of using a super complex algo. I mean, this is really a state-of-the-art algo. It came out last year to predict time series at scale. You could be predicting, you know, billions of data points with this, but you never actually write a single line of machine learning code. You just select an algo off the shelf, and you prepare your data, which you would have to do anyway, and you train, and then you predict, okay? So all you have to understand is how to use DeepAR, and then you can predict time series. And again, I would refer you to the research paper if you want to know more. Okay, let's look at a second example. So this one is another built-in algo, and it's for image classification. So we have a service, we have a high-level service called Amazon Recognition, which I'm guessing you've heard about, and it's great, but it's a general purpose service. So what if I need to actually train and build a model on my own custom set of images that are maybe domain specific and that are not classified and recognized properly by recognition? So we have a built-in algo for this. It's actually based on a deep learning model, which you could use in two ways. So you could actually you could train from scratch. So if you have a large data set of images that you want to classify, you could bring that to S3, train from scratch using that deep learning network, okay? That's one way. Or you could do what we call transfer learning. And transfer learning means you take a pre-trained version of that network, okay? A network that has been trained on millions of images, okay? So a network that already knows how to detect a lot of shapes and a lot of objects. And you can just retrain it for a bit on your own data set. Okay, this is also called fine-tuning. It's a very, very powerful technique because it lets you get to really high accuracy even when you have very little data, right? You don't need a lot of data here because the network has already been trained, and all you do is train it again, okay? So that's what we're doing here. Okay, so again, starts the same. I have to go and pick that container from the region I'm running in, okay? And here I'm going to fine-tune on, so the pre-trained network has been trained on a data set called ImageNet. So ImageNet is a reference image data set with millions and millions of images and thousands of categories, okay? So it already knows how to recognize a lot of things. But here, just going to take a smaller data set called Caltech 256, and as you can guess, it has 256 classes, okay? And it has a small number of images, right? Just 30,000, which is pretty small, okay? And that could be, you know, that could be typical of a data set that you have. Many different classes, but not so many images per class. And so I'm going to retrain my pre-trained network on Caltech 56. Okay, so I need to download the data set, upload it to S3, okay, no big deal. And then I need to define some training parameters, okay? So actually I can select the depth of the deep learning network that I'm going to use. For those of you who already do deep learning, it's a ResNet network, okay? So I'm going to use 18 layers, which is quite small actually. I need to define the size of the images, how many training samples I have, how many classes I have. So it says 257 because we actually have 256 classes, okay, objects, etc. and there's like a catch-all category. So that's why 257. Batch size, number of epochs, and as you can see here, I'm only training for 2 epochs, which is very, very low, right? Again, I can afford to do this because I'm just fine-tuning. I'm not training from scratch. And again, this is another of the advantages of fine-tuning. You can actually train for a very, very limited amount of time just with your own images and get very good results. So it's a fast and inexpensive technique. Okay, so these are my parameters. So I need to put all that stuff in a JSON document, okay, defining again the location of my data set, how much infrastructure do I want. So here I'm going to train on a single P2 instance, okay, the hyperparameters, etc., okay, where the data is, and all this stuff is really boilerplate, right? You can really cut and paste and use your own values here. Okay, and then I'm going to use the SageMaker API to create a training job. Okay, and this is an asynchronous call. So this is the low-level API in SageMaker actually. So I'm going to create the training job, and then I can use a waiter to see when the job is actually complete. Okay, so it trains for a while. Okay, and then the training job is complete, right? And then I can deploy the model. So I will first save the model in SageMaker, register it to SageMaker here, okay? And then I can create that endpoint configuration, which I was talking about earlier, okay? So here you see all the actual steps that are involved. So here, of course, I'm deploying a single model, and all traffic goes to that model. But this is where you could say, hey, let's have maybe yesterday's model and today's model, and let's split traffic 50-50 to make sure the new model actually works. Okay, so here's the actual endpoint configuration here. Then create the endpoint. Okay, so again, create an instance, deploy everything to the instance, wait for it to be ready, and then we can predict, right? So I can grab any of the images. So this is a bathtub image, which is one of the categories in Caltech, 256. So just grab one of them from the web, and we can display it. So yeah, it is a bathtub. And then I can pass that image to post it to the endpoint, okay? And read the highest probability. And you can see the categories here. Okay, baseball glove and bathtub and beer mug and all kinds of things, 256 of them. And so the highest probability is actually the one corresponding to bathtub. Okay, so this is how, in again just a couple of epochs, which took maybe, I don't know, 10 minutes to train, I can take a pre-trained deep learning model, apply my own data set to it, and just get really good results. Okay. So what if you wanted to invoke this thing from your app? Because here I'm using the SDK in a notebook, and it's probably not, it's good for experimentation, but it's probably not the way you're going to do it, right? You want to deploy that model to the endpoint, and then you want your application to actually invoke it. Okay, so can we do this with a proper app? So here, I'm going to use an AWS open source project called Chalice that lets you deploy Python web services in the API gateway and Lambda. So literally going to deploy a serverless app that lets me invoke and pre-process and post-process data with that endpoint. So it's actually not a lot of code, right? It's not a lot of code, and if you have Python programmers in the room who use Flask, this is very, very similar to Flask. It's like Flask for serverless, as I call it. Okay, so I'm going to create a web service to which I can post, and so I'm going to post a base 64 encoded image to this API. Okay. So the first thing that I need to grab is, of course, the data in the body, decode it. I'm going to grab the endpoint name, which is stored as an environment variable in the Lambda function. And then optionally, I have a top K variable that tells me how many probabilities do I want to see actually for this image. Because most of the time, I guess I don't want to see 256 probabilities. I don't care. Maybe I want the top 5, right? So if that top K variable is passed and says 5, then I'm just going to output the top 5 probabilities. Okay, and then I get a SageMaker client. I invoke the endpoint, right, for the SageMaker endpoint. I decode the result. And I just sort those 256 probabilities and output the top K, right? So pretty simple code. So this is how you would invoke it. So let's deploy this thing, which is as easy as chalice deploy. Okay, and so this automatically creates a deployment package for the Lambda function, deploys the Lambda function, creates an API gateway, and here's the endpoint that has been created. So there you go, right? And now I can invoke that thing and see how it works. So I have a small script to do that. Okay, so I'm going to take a couple of sample images. And yeah, it's an American data set, so hamburger will do just fine. And I am just literally posting posting that base 64 encoded image to my Chalice web service, which will invoke the SageMaker endpoint, get the 256 probabilities, and just output the top 3 in this case. So let's try and do this. Hopefully it's going to work. Yes. Okay. So it tells me the top 3 probabilities for this image are 95, 147 to 26, but 95 is really the one that I care about, 97%. So now either you trust me that 95 is the hamburger class or you don't. So I can feel that you don't. You're right, I'm French. No. Don't trust me, never. Never trust an evangelist. Anyway, so let's check. Let's go into that, into that data set. Uh, 95, yeah. Hamburgers, right? So, see, I didn't lie. So, this is an example of creating a small web service that will do maybe pre-processing. Let's say maybe you need to inject additional data into the prediction, right? So maybe you would pull it from a backend somewhere, DynamoDB, and then call the SageMaker endpoint. Most of the time, you will need to do post-processing as well, filter out the probabilities like I did here. So it's just a very simple and inexpensive way to get the job done. And as you can see, deployment is really a breeze, right? Chalice is a really, really good tool, not only for this. All right. So here's an example of going all the way, training a model, deploying the endpoint, and then actually invoking it from, let's say, an external web service. All right. Do we have time for one more? Yeah, I think we have. So let's go for this one here. So far, I showed you how to use the Python SDK to get the job done with SageMaker. But there's another SDK for Spark, okay, which is available in Scala and PySpark. So you can actually invoke SageMaker from your Spark cluster. Okay. Why would you want to do that? Well, as you probably know, Spark is extremely good at data processing, and it's a popular choice for data cleaning, data filtering, aggregation, etc. And chances are, if you have a large, complex data set, you have to do that before you train your model. Okay? And again, Spark is a popular way to do that. So you could create a Spark cluster with the best instance type, okay, for that job. Do the cleaning, then create the training job on SageMaker and train with the best instance type as well, and then deploy the model and then run predictions from your Spark cluster. So here, I'm going to build a simple spam classifier. So it's a simple data set. It's got 2 files, one with spam, one with not spam. one line per message. Okay, so here, of course, I'm going to do really basic cleaning. You could probably do a lot more and a lot more complicated things. So here I'm just putting everything into lowercase, removing everything that's not a letter, so punctuation, numbers, etc., and removing white space. Okay, so I've got my two data frames here in, or RDDs actually, in Spark containing those data sets. Okay, and now what I want to do is I'm going to build feature vectors from those text messages. So I'm using an object called hashing TF, which will actually build word vectors, so 200 word vectors with a word index and a word frequency. Okay, and the intuition here is some words, if you see some specific words in a message, it's probably spam, right? Spam tends to be really, a caricature. So that's the basic idea. We want to take the top 200 words and build vectors for spam and not spam. And hopefully that's going to help us figure out which is which. Okay. So this is what I'm doing here, splitting the lines into words and building those vectors. So here's an example for it. So that's a proper sample. So it's a vector, and that message has word 25, 41, 99, 146, whatever they are, and we have the word frequencies here. Okay, and this is actually what we're going to classify. We transform the words into integers and the messages into word vectors with frequencies. So I'm going to label spam messages with 1, non-spam messages with 0. Okay? So this just adds a label, as you can see here, to my samples. Then I'm going to put the two together, right? Shuffle them and split the data set into training and validation again, splitting 80-20. Okay? So now I've got two RDDs, one with the training set, one with a test set. Okay? So now I'm ready to train. So I'm using XGBoost, the XGBoost classifier, to do this, which is one of the built-in algos in SageMaker. And this one is a bit different compared to the others. It does require data to be in a specific format called libsvm. Okay? So no big deal, because there's a function in Spark to do that. Okay, and so that's my data set right there. Okay, so just convert it again, just like we converted to JSON for a DeepAR, we need to convert to libsvm for XGBoost. Okay, and then I can just configure my training job. Okay, so using the Spark SDK for SageMaker, I'm going to create that XGBoost estimator, define my training infrastructure, define my prediction infrastructure, define some parameters for the training job. I'm really building a binary classifier here. And then I can train, okay? So from the Spark cluster here, I'm firing up a training instance just like we've done before. And so SageMaker will actually train using the XGBoost built-in algo, just like we've done before, okay? And it terminates automatically. Okay, it deploys the endpoint, and then I can predict. Okay, so once again, I'm going to take my test set, convert it to libsvm, and just invoke my model from Spark. Okay, invoke the SageMaker endpoint from Spark, and get predictions. Right. So this, you really get the best of both worlds here, because you can configure and size your Spark cluster in the best possible way, right? Using the best instance type, the best size, etc., etc. And then you can do the same for the SageMaker training cluster and the SageMaker prediction cluster. So maybe you want M4 instances for Spark because you need a lot of memory. Maybe you need P3 instances to train because you want GPUs and you need a lot of power. And maybe you need C4 or C5 to predict because you want very fast predictions, right? So by splitting those three concerns, right, ETL, training, and deploying, you actually get the best of all those worlds. versus trying to do everything on a Spark cluster, which will be some kind of compromise, right? And here you can really avoid that compromise and do everything yourself. And of course, we could compute accuracy, okay? So looking at my predicted data, okay, so that's the original label and that's the predicted label for those samples. I can count the number of predictions that are actually correct, divide everything by the total number of predictions, and well, this gives me 97 plus accuracy. I'm not sure if it's good or great, but okay, it's not too bad. Okay, so here's an example of mixing both. Okay, mixing both SageMaker and Spark for the best of all worlds, I guess. All right, I think we're done. So if you need more resources, I would really point you to. Let me show you maybe one single slide, if I can find my deck. Here we go. If you want to get started with SageMaker, come on PowerPoint. These are the good links to look at. There we go. So obviously the product pays for SageMaker. That has also customer references, etc. The SageMaker examples is the GitHub repository where you will find all the notebooks that show you how to use SageMaker in many different ways, the built-in algos, etc. The SageMaker SDK. There's also, like I said, a Spark SDK, which you'll find on GitHub as well. And if you want an overview of SageMaker and how to use it in different configurations with TensorFlow and so on, this is the YouTube video to look at. Okay. And last but not least, my blog, where I tend to post a lot of stuff on deep learning, MXNet, SageMaker, and you'll find more examples there. All right. Thank you very much, and enjoy the rest of your day.